My name is Annika. I am the co-author on this particular paper. This is a presentation on data mining techniques to study therapy success with autistic children, and it is based on a paper of the same title. Autism is a developmental disorder that is characterized by several different symptoms, as you can see up here. The current research that leverages information technology focuses mainly on the interaction of the autistic person with the outside world. It focuses on social and interpersonal skills, looking at doing play acting with computers, communication difficulties, such as talking. If autistic people do not like to talk, they can sometimes look at pictures and point to pictures in order to communicate with other people. They also look at rigidity of thinking. People with autism are very literal. If you say, "Cat got your tongue," to ask why they're quiet, they'll look for a cat and wonder what in the hell they're doing with your tongue and what does this have to do with why I'm not talking. They just don't understand. It doesn't occur to them to look for that kind of information. Specifically with data mining research, focuses on these three main areas. The first, biological associations, looks at things like gene mapping. It looks at finding out why is this happening biologically to the people. The second looks at the drug-related treatments, looks at the chemical balances in the brain, what does it do to them, things of that nature. The third is the area that we're focusing on, behavioral-based data mining. There are two types. The first looks at a behavior profile, looks at different kinds of people, how do we expect them to act, how do we expect a specific child to act under circumstances. The second is a therapy profile, which looks at how do different therapies work, when do they work, what types of things do they change with the behavior, and when is it good. This last one is what we're focusing on with our particular research. So we're looking at therapy profiles and how does the therapy work on different children. Our data set was obtained from the Claremont Autism Center. There are several sessions taped per condition to give you a range of information about the child. This information the videos are then independently evaluated by two different therapists who have been trained to identify different behaviors. The behaviors that they look at are identified as either present or not present. And the four positive behaviors that they look at are social behavior, appropriate play, appropriate speech, and compliance. The four negative are non-compliance, inappropriate speech, disruptive behavior, and self-stim. The self-stim is repetitive motion that would stimulate the child when there's nobody else in the room, and it's considered very negative. This data is recorded in 10-second intervals, so they look at, for every 10 seconds, was behavior noticed, and it's either as a 1 or a 0. So if they expressed social behavior twice in the 10 seconds, it only gets marked out as present. Our approach for the therapy profile, we wanted to focus on an increase in the positive behavior and a decrease in the negative behavior, obviously looking for, does the therapy work? The therapy is intended to help the child integrate into normal society, which is the increase in appropriate behavior, and also limit the amount of negative stigma that's attached to the person, so that's the lowering of negative behavior. We wanted to use symbolic machine learning to create human understandable content. We wanted to be able to give the caregivers and the therapists information that they could use, that they wouldn't have to go to somebody to interpret this data, which left us with decision trees and association rules within data mining. The decision trees are hierarchically created rule sets, and it's made in the shape of a tree. We can also rewrite these rules, rewrite the tree as a set of conditional rules. The association rules come out as if-then rule statements. For the pre-processing, in order to generate more data that we could use with our data mining, we combined the behavior counts from 10-second intervals into minute intervals. So we took six sets of the 10-second intervals and combined them to make 1 minute. We also took all four behavior types that were appropriate and labeled them collectively as appropriate, the four negative, and collectively identified those as inappropriate. Once we did that, we looked at the information for each child. We identified what is high for this child, what is a low instance of the behavior for the child. Because the behavior can be so varied and the symptoms can be so varied, it's important to make sure that every time you look at information, it's what is typical for this child under these circumstances. If you tried to do it over several different children, that would throw your data off immensely. So these are the general results that we saw. We saw this is 100% of the behavior, and as you can see, starting out before therapy, we see an initial negative initial appropriate behavior level of 28%. So 28% of the child's behavior was inappropriate. That number dropped to 9% during therapy, so it was a marked improvement. And then the child backslided after they left therapy, so it went to about 10%. The decision trees. We started out trying to predict either appropriate or inappropriate behavior for the children, and we were not successful in finding a good decision tree. The idea was, is this child going to act one of two ways? So we moved to looking at predicting either high or low levels of each of the behavior types. We identified a baseline by using the most common label applied, and these are the results when compared to our decision trees. As you can see with the inappropriate behavior here, we were not able to improve on the baseline, and thus the decision tree was not acceptable. However, before treatment and during treatment, we were able to markedly improve on the baseline, and thus they were definitely significant findings. The decision trees for the appropriate behavior. This is before treatment. The decision tree identifies the most effective feature, which is interactivity, whether or not the person was interactive with the child, and then moves down a node to who accompanied the child, whether they were by themselves or who they were with. As you can see, without interaction, there is a low level of appropriate behavior. When there is interaction and they're accompanied, there is a high level of appropriate behavior. During the treatment, we have a very similar tree. We've now added the therapist onto the nodes, so you can see that the adding the therapist into the mix didn't significantly change the decision tree. And then this is the decision tree for post-treatment, which was not a very big improvement on the baseline. For our association rules, we looked only at rules that had a minimum of 10% support and a 90% confidence rate, and also we were looking for either a high or low level of behavior predicted. For appropriate behavior, we were not able to find rules that in the before treatment or after treatment segments. However, we did find interesting rules in the during treatment segment. The rules basically confirmed what the decision trees had to say and then gave us a little bit more detail on those. As you can see, the confidence rates were pretty high with them. For the association rules on inappropriate behavior, we were not able to find rules for the pre-treatment or during treatment. However, after treatment, we found that if they were alone, then there was very low inappropriate behavior, and if there was a stranger in the room and the stranger was not interacting with them, then there was also a low instance of inappropriate behavior. So in conclusion, we found that behavior was more predictable during treatment, which was something that the therapist and the caregivers could both confirm to us. The decision trees for high and low appropriate behavior before and during treatment were fairly accurate. After treatment was not as accurate, and we think that increasing the data set for after treatment would definitely improve those results. We found that interaction brings out appropriate behavior in the children, and conversely that non-interaction does nothing to the appropriate behavior. The association rules serve to confirm our results for the decision trees, and gave us a little bit more detail, specifically that if the child was alone, there was low appropriate behavior as well as low inappropriate behavior, so the child really didn't exhibit very much behavior at all. And also that when there is a non-interactive stranger with the child, that there is a low level of inappropriate behavior. For future research, we intend to look at how each of the individual behaviors are affected by the setting, since we had to combine since we had to combine all of the behaviors in order to increase our data set. We would like to look at how each of the behaviors function individually. More data would obviously help us increase our decision trees as well as improve the accuracy of those decision trees. And following on that, finding a way to automatically code the data, the video data, would also improve our data set. Right now we have 2 therapists looking at minutes of video. It's real time, and then they have to put that information into a computer, which obviously takes more time. And then also looking at developing behavior profiles to go with these therapy profiles. Use them in conjunction to help predict, for this type of child, this therapy will help improve their behavior or help move the caregiver towards a specific goal that they want for that child.